Welcome in the series Fun with MATLAB. My name is Anish Yadav and I am working at MATLAB Helper. In this video, we are going to see how we can select the best technique for data transformation to build optimized machine learning models. First, we will discuss about data distribution, and after that, we will visualize same thing in the MATLAB. We know that our machine learning model would be more accurate if data is normally distributed, since normally distributed data follows the empirical rule of probability distribution. If the distribution of data has more peaks, we usually use compression techniques or transformation techniques to bring it close to normal distribution. The data close to normal distribution is transformed by square root, cube root, log and reciprocal transformations. But suppose that if data is already compressed, then we use power transformation to make it normal. In this video, I assume that you all are familiar with fundamental understanding of the basics of transformation techniques and MATLAB coding. And right here, when modeling the machine learning algorithm, we are going to see which transformation technique is best for particular data. You can see the code over here. Generally, to compress data, we use square root, cube root, log and reciprocal transformation. First, using the random function, I generated normally distributed data. When we check the histogram, you will see that the data is normally distributed. After that, to analyze the difference between different transformation techniques, I just plotted different compression techniques on the same graph. If I run the code, I can visualize transformation techniques. Right here, I am going to conclude the difference. The first point is that the log transformation technique is stronger than the transformation of cube root technique, and the transformation of cube root technique is stronger than the transformation of square root technique. The second point we can visualize, if we apply log and square root function to a negative number, we will get complex number. So we can conclude both transformation techniques are not applicable when data has negative observations. Also, the log transformation techniques does not applicable to zero values. If we check reciprocal transformation for the same data set, we can conclude that it's most powerful technique because it is compressing data more for a small change in corresponding original dataset value. Now check power transformation techniques. Generally, higher the power, more powerful that particular transformation. You can see here that the cube transformation is more efficient than square transformation. We should also note that if we apply square transformation to negative number, we can get positive number. So for the negative numbers, square transformation is not valid. In the end, I would like to ask you one question. How we can get the original data set if the data is log normally distributed? And in the comment box below, you all are requested to write your reply. Check our MATLAB fundamental course to get more insight about symbolic functionality. Thank you for watching this video. Do like this video if you found it helpful. If you have any queries, post them in the comments or get in touch with us. Follow us on LinkedIn, Facebook and subscribe to our YouTube channel. Education is our future, MATLAB is our feature. Happy MATLABing.